Welcome back to real time digital signal processing, a lab basically. So, last class we had a problem with the code loading into the thing. So, today I will show you how you, if there is any problem, how you can load it. So, we are discussing about the adaptive filters in non-real time. So, these were the equations, that is updation of the weights here and error calculation, and then the output calculation is here, and this is our LMS algorithm which will be running it in non real time. Okay. So, these are the parameters what we have it, that is 2 cos 2 pi NF by Fs is our this thing desired signal, and the input is chosen as a sine of a signal itself, that is 2 pi n f by Fs. Okay. So, here f is equal to 1 kilohertz and sampling frequency chosen is 8 kilohertz. So, adaptation rate mu is going to be set with 0.01 and order of the filter is 21, and we know within 60 the iterations. So, the system will converge to the error is going to come down, and then output will be equivalent to input. So, this will be the desired plot what you can see it. So, this is going to happen in non-real time. So, we can change the adaptation or convergence rate and then see how it is going to behave. So, what we will do is we will go to the Code Composer Studio. As I said, there was a problem in the previous class what we had it. So, all the directories, if you go into the thing, I have loaded all the labs thing in my D drive basically. So, that is in CCS 9 what I have all the files basically running. So, this is my working workspace basically for the Code Composer Studio. So, yesterday I was seeing this and then I was having a little problem. So, what I did was, so go to the file, if you are by mistake all the complete workspace is cleared, you can go and then you will be opening the projects from the file system. So, if you give this directory, automatically all the files gets reinstated in the directory. As you can see here, I am having from the day 1 whatever demos I have been doing it, it is available here. Okay. So, this is how you can get back all your directories and then you can run. So, this is a non-real time what the demo is going to be. So, what we have in this is a main.c file, what we have it, as it is pointed out, this is the desired signal. What we want is 2 cos 2 pi into t into 1000 by Fs, f we said it is 1 kilohertz. So, the noise signal given as a sine, that is 2 star pi t 1000 by Fs. So, this noise signal has to be eliminated and then we should be getting the desired signal at the output. So, we will see how we are going to get the thing. So, this is desired and I have a y out and then error signal. So, fine. In this case the w, as we said, the weight function. So, it is assigned to 0 initially, even the x 0 will be getting the first noise signal here, new noise sample, and d will be our desired signal and y is going to be 0, and the variable that is a filter output what we will be calculating y plus, that is whatever weight you have computed into x of I, and error is computed as d minus I, desired signal minus y output, and you will be updating your weight w of I with w of I plus mu into error, basically what you have computed here, into input, that is x of I. So, in this case mu is assumed as 0.01 in this case, that is what the initial. So, you can change it to 0.02 next and then see the convergence will be faster. And in MATLAB pi value automatically takes, but here in Code Composer Studio in C file you have to define your pi value also. So, it is defined up to 7 decimal places, whatever length you want to define your pi you can define it. And sampling frequency we said 8000, order of the filter is 21, and then our the number of iterations is chosen as 60. So, we will be calculating the update the error function and the delay, because x also has to be further this thing delay line has to be, input line also has to be updated. This is how we will be updating the delay line, and we will be putting last desired of t will be equal to d, and then our y out will be y, and then error function will be e, and then once it is done you can call it as done. So, what we do is, because as we said the return function, the handle is written elsewhere, it is not in this memory. So, we will put a breakpoint here, and then since it has been tested, so what we will do is we will directly go for debugging. So, you will be seeing that if there are errors, it will ask you whether with errors it has to go for the debug. Since no errors, so it will go for the debug. So, now I have as you can see, the handle is in the main the flower bracket where it is flashing. So, it is ready to run with the thing. So, I have put the breakpoint as I said. So, we will run this code, and then you will see it is going to run up to printf. So, that will not have any error. So, you will be seeing that the sum of the values, what it has got changed and where location, if you want to check in the variables what we have the values here. So, now what we will do is we have to plot, that is what we have in the thing, output what we have to see it. So, what are the thing? This is the desired signal what it should look like, and this is the adapted signal, and this is the error. You will be seeing it, it is initially high and then it is coming down. So, we will observe whether we have got these results. Go to tools, and then we will put the graph single time. What we want is iterations is 60, and all of them have been declared as float. So, it is a single precision 32-bit floating point. So, the first one will be calling it as desired okay. So, you are seeing this is a cos what we have it. So, now again we will plot the other one single time. So, this also 60. Same thing, it is a floating point what it has been chosen here, floating point, and start address is going to be, I will call it as y out is what we want to have the thing. So, I will give y out. So, you will be seeing that initially it is low, and then after that it will settles down. So, now we will see how the error is going to look like. Again graph single time, I will give this also 60 iterations, and this also declared as float, floating point, and start address will be error function what I want to plot it. Okay. So, you will be seeing that initially error is very high, you are seeing it, and then later on it is coming down. So, it is 60 samples is enough to get your desired output, that is what it is shown here, it is there, and then you are settling down. So, it has whatever the desired signal. So, what you are getting at the output. So, you will be seeing this is the desired signal. So, what we are trying to achieve, initially we had the noise as sine, so which comes out as the cosine here. So, that is the desired signal, this is the output. This is one of the demo what we had the thing. So, we will stop here, and what is the next demo we will be taking in our Code Composer Studio. So, this is adaptive filter for sinusoidal noise calculation. So, here it is the adaptive noise interrupt driven what we will be doing it. So, what happens here is the same thing, signal frequency is 2500 what it is chosen, with an added undesired sine wave signal noise frequency which is 1200 hertz. So, one of the two inputs to our board basically here to the noise cancellation structure, and then present the signal plus noise from the primary. A cosine wave that is reference noise with a frequency of noise frequency, that is what we have chosen 1200 hertz, represent the reference noise signal and is the input to n coefficient adaptive FIR filter in this case. We want to remove this as a noise, and then it will be removing the noise from the signal, and you will be hearing only one tone. So, signal reference noise is strongly correlated with signal noise, but not with the desired signal. Okay. At each sampling instant, the output of adaptive FIR filter is calculated and its n weights are updated, and the contents of the delay line x are going to be shifted. So, same way we will be calculating the error signal is overall desired output of the adaptive structure. So, it consists of desired signal and additive noise from the primary sensor, that is signal plus signal noise is included, from which the adaptive filter output y n has been subtracted, and our input signal used in these examples are generated with the program, and both the input signal plus noise and the output signal are output via the AEC 3106 codec on right and left channels respectively. This is how what we will be running the thing. So, you will be putting the demo here. So, what happens here is signal what we have it. The undesired 1200 hertz sinusoidal component of the output signal error is gradually going to be reduced, cancelled, while the desired 2500 hertz signal is going to remain. Okay. So, to faster rate of adaptation, your beta or your mu can be changed. It is too large, the adaptation process may become unstable. So, this is your signal and this is the reference noise, what you will be generating it and putting it, and you will be hearing at line out right and then left what you can hear the error separately. Okay. So, if you have a separation of left and right, you can independently look at your CRO also and then see that. So, what we will do is we will go for the demo. What I need is the adaptive noise interrupt driven. So, I have the thing already built in. So, if I click on it, it becomes an active debug. So, we will see that this is the interrupt driven what we have it. So, we will be getting the data on the right and left channel, and then you will be it uses the delay adaptation what you have it, and in this case we will be using the GPU IO get input from left channel or right channel. So, you can use the dip value 0, then it is going to output fixed out. So, if it is otherwise if it is 1, it is going to put adaptive out. Okay. So, what we will do is we will run the thing, we will compile it, debug it and then run. I can close all these things. So, I will run the thing. Initially you may not hear the both the sounds. You are hearing the noise, that is what the thing. So, by changing the depth switch, we can hear the clear sine wave basically. So, what I will do is I will show you by a graph basically what is the thing we have it. Out type will have adapt out, hopefully it will plot it. Some will plot some 200 samples. So, it is In this case it is showing you a flat. So, that is the error what it is coming out of our this thing audio signal. Okay. By a dip switch I have not taken the thing, you can experiment it by changing the GPIO dip switch. So, you can hear the other sound. So, the next one what we will continue with the thing is adaptive FIR filter for system identification of a fixed FIR filter as an unknown system. So, what is it? Here also you have a dip switch basically is to select either FIR out, the output from the fixed unknown FIR filter, or adaptive FIR out. So, the output from this FIR filter what you will be getting it as a output. Return to the right channel of line out on the kit, and what you have to do is the error signal is always returned to the left channel of line out. So, that is what you will be one of the thing what you can select, but your left channel always error what it will be coming. So, this is a unknown system you are trying to identify by adapting the weight for the FIR filter. So, it uses a band pass filter that is 55 dot coefficient, that is 55 coefficient FIR band stop filter centered at 2 kilohertz. Okay. So, you can change the number of weights coefficients from 60 to 40 and verified slight degradation is going to happen in the identification process. So, we will see the thing using CCS. This is the system identification. So, you have the system ID interrupt dot C is the code. What I will do is I will show you this code. So, here the weight is that is W length is 256 and then the beta value or mu is 10 into e power minus 12. The learning rate has been selected and you will be getting the left sample what you are going to get from the board, and then you will be delaying it and then working on it. So, this is the adaptation what will be that is initialize the adaptive filter weights and delay line. So, WI is also made 0 and delay line is also made 0, and you will be adapting it to the system. So, we will run this code. You will be hearing the noise. Sorry, I am unable to change the dip switch in this case. You can try it yourself and then see that you will be getting the output correctly. So, the next one what we will have is the same thing. There are different this thing what is it, fixed FIR as an unknown system with weights of an adaptive filter initialized as FIR band pass filter in this case. So, that is ID FIR init coefficients dot h what it will be using it, and then what is coming out of the left sample. Okay. This is the adaptive filter output left sample, you are having the left sample, and to the LDAC what it is going. Okay, one thing I forgot to give the thing is it is going to read from the ADC and then this is the DAC output. So, what I have to provide is one of the sine wave what I have to provide it as an input. So, for running this test signals, it is given some of the test signals will be known, some of the tones are there. Okay. So, I can provide sine 1000, this is a sound input to the system. You will be seeing that it is continuously running. So, we will see whether the left sample has come or not in this case. So, we will output it and then check. Sometimes what happens, whatever input I have taken the thing, whether I have got it out or not, this way what you will be checking the thing. So, we will recompile it. So, this is the input which is coming out. Okay. So, that is how you will be checking whether you have got the input into your system or not. So, the input is coming. So, because I am taking left sample and then I am outputting it, whether it has adapted or not, one has to look at it, because there is a problem at the So, this is the noise what you have it. So, you are outputting the noise in this case basically. So, you will hear the noise anyway, already you have heard it. So, I am showing that what is the output happening. Okay. So, the noise is coming out of the thing. So, once it is will push this little down, so that I can output my either filter output, what we can output it here. This is how you will be changing the thing. So, FIR out, what I want to put the thing. So, we will do debug and then see whether I am getting the. So, as you can see, I have faced this thing, error in the thing. So, unless I solve this, there is no point in line 27 what it says. So, I have to come out of the debug mode. I will go to the thing. Okay. As you can see, I have not removed, it was 0 what it was taking. So, there was a mismatch in the thing. So, I have to correct the error and then recompile it. So, when there is error, do not go and then load it onto the board. As you can see that there is little error in the whatever the FIR filter what it is getting adapted to, that is filter coefficients, trying to remove this noise, and then it I should be getting clean sine wave, but still there is an error. So, this order is may not be sufficient for it. So, you may have to go to higher order to remove the noise from the thing. So, it is a little bit reduced, but it is still getting overlapped. So, you have to fine tune and then work on it. So, what is the next application what we will see using this thing in the board, that is idea of fixed IIR as an unknown system in this case. So, earlier we have seen it as FIR. So, this is the pseudo random generation what you are doing it, IR filter through which you are passing and then looking into the thing. So, here it is used as elliptic dot coefficient, what it is going to be used for this purpose, the filter length, that is because we know that it has to be one of the thing, either I can use Chebyshev or Butterworth or elliptic. Elliptic has the minimum, what we have seen in the class is that it has both ripple in the pass band and then stop band. So, which has a very minimum order for the thing. So, we will go and then see whether we can work on this. So, this is IAR. So, I have adaptive IAR here. So, we will make this as an active debug directory and then I will close the C file and open IAR adaptation. So, you will be seeing that elliptic dot coefficient what it needs the thing. When I open it, so you will be seeing that number of sections what it has is 3, that is numerator sections are 2 basically, as you can see the thing, and then denominator what you have it. So, number of sections what we have it is, that is second order, this is the numerator, the denominator of the first section, and numerator and then denominator of the last section what we have it. Okay. That is number of sections what it has is 3b. Okay. Order is 2 sections what we have it, that is fourth order filter. First is the second order, second stage is the second order section what we have it. So, these are the B coefficients and these are the A coefficients what we have it. So, when we run the thing, we will build the thing. Here adaptation rate is chosen as 1e power minus 13 basically, as you can see in the code value. So, we are passing the same sine wave what we have kept it. So, it is continuously running. Okay. So, we will see that how this is going to react to the noise and then input signal. Okay, you have the adaptive adapt FIR out and adapt FIR, both of them are output both right and left. What you are seeing the thing, almost it is getting the noise, it is not completely eliminated with fourth order what you are seeing it. So, you are using the update adaptive FIR filter coefficients in this case. Delay line what you are doing it. So, still the noise is left out. So, it needs further training and then the order of the filter is very low in this case. So, it is unable to adapt itself to the noise. So, this example, because I said it is a audio wave file what we generated in the last class, because it needs longer time to adapt itself. So, it was taking longer time, that is why I shown this demo in the last class. So, this completes the adaptive filter up what I will say for different applications, how we are going to run it using the board in real time. So, whatever data, how a system ID identification it happened and how the noise is going to be cancelled, and it can be non real time or real time what you can give the thing. So, one more way of doing it is you can give separately the noise in one channel. Here it is mixed and then sent it as an input to the system. So, one of them can be mic input, the other one can be line input, what you can give and then mix and then match. So, that is what I was telling. So, you can play around this board the way you want to give the input and then what you want to hear at the output. So, thank you for listening to this lab.